summer school that we are planning to do is not going to be anything about what you do in school. It is going to be completely different. It is known as engineering in motion. What that means is we are going to be doing a bunch of things that will help us understand how moving things are designed from scratch. How many of you have heard about mechanical engineering? Lot of you, right? So whenever something is moving, whether it's a robot dancing, whether it's a linkage, whether it's the door opening, any mechanical movement is part of mechanical engineering. Now, we don't get a lot of chance to do these kind of hands-on engineering things in the classroom. So the plan is to have a 5 days intensive hands-on workshop, very little of reading and writing, where we can understand if we want to design a kinetic structure. When I say kinetic structure, it means a moving structure. How do we go about it? The three main criteria in designing any kind of moving structures are gears and linkages. What are the kind of gears? What are the linkages that happen? How should we put two things together? How do we convert linear motion into rotational motion? These kind of things are what this entire workshop is going to be. We are going to be making two main projects. One project is known as an automata or a kinetic sculpture. A kinetic sculpture is something which probably would look like this, which is essentially understanding how cams work, how do we create different kinds of motion, and then use our own creativity, work in groups. It looks very simple, but trust me, it is not very difficult, but it is something that is done in engineering first year usually. So the idea of this project would be to understand cams, linkages, gears, and create moving projects while working in groups. So you will probably be divided into groups of 4 or so, where on the first 2 days, you will make your own thing, understand the basics of the cams and the gears. But the next 3 days, you're going to be, well, we'll see whether it's 3 or 2 days. But then later, you will work in groups to create your own storytelling project using movement. And there you will be using your idea of gears and cams that you have learned to create a scenario and how it works. So it's going to be a lot of hands-on, a lot of design thinking, completely creative, but you will get a first-hand idea of if you were to design a moving thing, whether it's a robot tomorrow, whether you design and you get into product design, whatever it is, the overlying theme will be to design a project from scratch, working in a group while understanding the kinetic considerations. Does that make sense? So that's one part of it. We'll also add motors if required. Right now, what you saw was there were no motors. People were moving it by hand. We will also use, we'll see if we can incorporate motors to start making it move automatically. So this is something we'll start from scratch. The boxes, the gears, the cams, these will be, we'll learn about them, but you are the ones who are going to make them. That's number one. The second project, so you could go fancy, all fancy, you can create a wave. How do you create a wave moving part? So this is where your understanding of the cams will go. So that's going to be 3 days of the project. Okay, 3 days, 3 hours. The next part which I want to do is take this a bit forward. And whenever we are talking of things like robots or any kind of movement, which is controlled movement, there are different kind of linkages. So what makes a walking motion? What makes a crawling motion? How can we put these linkages together to make something which replicates walking? Because these linkages are the ones which are usually used by people who make, let's say, humanoids or robots. So we are going to understand how linkages work. Again, a very mechanical engineering thing, but we are going to do it hands-on, and the idea is to create moving things which could either be crawling, they could have a motion which is running, they could have a motion which is, going wriggling. So then again, you will have your entire flexibility to design something in terms of the moving sculpture that is going to be there. Again, working together, bringing electronics and linkages and mechanical motion together. Okay, so that's the main idea, which is why it's called engineering in motion. How do we engineer things